Welcome to The Explainer. Today we're going to talk about moving past simple gut feelings and really getting into the numbers. We're building a powerful toolkit, one that's going to help us quantify all that uncertainty out there and make smarter, more rational financial decisions, especially when things look, a little cloudy.
All right, so let's just jump right in. You know that feeling, right? That hunch, that good feeling you get about a stock or an investment? We've all been there. But here's the thing. In the world of finance, a feeling, well, it's just not enough. So the real question, the one we're tackling today, is how do you take that intuition and turn it into something solid, something you can actually work with, like a number, a probability, a real structured decision? That's exactly what we're going to figure out.
Okay, so first things first, we're going to start with the two absolute pillars of any solid forecast. Before you can even begin to think about what the future might hold, you've got to have a way to measure two fundamental things. First, what's the potential reward you're shooting for? And second, what's the risk you're going to have to take on to get there?
So, our first tool in the kit is something called expected value. Now, the best way to think about this is it's your single best guess for what's going to happen. It's not just a simple average, though. It's way smarter than that. It's a weighted average that really takes into account how likely each possible outcome is. Seriously, if you had to put all your chips on one single number, this would be the one.
All right, let's see how this actually works. Look at this table. We've got a few possible sales figures, right? Everything from a huge blockbuster $70 million down to a more modest $25 million. And what we do is we take each one of those numbers and multiply it by the chance of it actually happening. Now check this out. The most likely outcome, that 70% chance of hitting 40 million in sales, that's the one that has the biggest impact on our final number. It carries the most weight. And when you add it all up, boom, you get your single best guess, an expected value of $37.75 million.
But here's the really crucial part. That $37.75 million forecast is just one number. It's a single point. But reality isn't a single point, is it? It's a whole range of possibilities. Sales could soar to 70 million or they could crater to 25 million. So knowing the average just isn't enough. A truly complete forecast has to capture that uncertainty, that potential for surprise. You have to measure the risk.
And how do we measure that risk? Well, that's where our second tool comes in, variance. This is just a powerful way to quantify how spread out all those potential outcomes really are. Think of it like this. If you have a low variance, it means most of the results are going to be huddled up really close to your expected value. It's a pretty certain forecast. But a high variance? Whoa! That means the results could be all over the map. And that is a much, much riskier situation.
So, how do we calculate it? Well, we look at each possible outcome, see how far away it is from our expected value, we square that difference. That's just a math trick to make everything positive. And then, just like before, we weight it by its probability. You do all that, and in this case, you get a variance of 96.18. Now, I know what you're thinking, that number doesn't mean much on its own, but here's the cool part. If you take the square root of the variance, you get something called the standard deviation. And for us, that's about $9.81 million. Now that's a number we can use because it's back in dollars, just like our original forecast. It gives us a real intuitive feel for just how big the risk is.
Okay, so we've got our basic tools down for a static, one-time forecast. But let's be real. The world doesn't just stand still, does it? New information is hitting us constantly. So the next question is, what do you do when the game changes? How do you update and refine your forecast on the fly? Let's dive into that.
So imagine this scenario. It's a classic problem in finance, right? You've done all your homework. You've built this really solid model for a company, say Bancorp's earnings. But the whole thing, its accuracy, is basically at the mercy of some huge external event you can't control, like what the central bank is going to do with interest rates. This means our initial forecast can't be the final word. It's just a starting point. It has to be a living, breathing number that can adapt.
A great way to handle this is to map everything out with what's called a probability tree. It's exactly what it sounds like. It all starts with the first big branch, the main event. In our case, the economic environment. Let's say after doing our research, we figure there's a 60% probability that interest rates are going to decline, which would be great for Bancorp. And that leaves a 40% chance that they'll just stay stable.
And just like a real tree, from each of those main branches, smaller ones sprout out. So if rates decline, that doesn't just lead to one outcome. There's still a range of possibilities for earnings. And the exact same thing is true if rates stay stable. What you end up with is this incredible visual roadmap of every single potential future for Bancorp's earnings. It's all laid out right in front of you.
And this is where this whole structure gets so powerful. It lets us calculate something called a conditional expected value. Now that sounds fancy, but all it really does is answer a super important question. Okay, my original forecast was X, but now I've got this new piece of information. I now know that interest rates are going to be stable. So, given that, what's my new, updated best guess? It's a way to react intelligently to new data.
And check out the payoff. Our initial what-if forecast for Bancorp's earnings per share was $2.34. That was our best guess before we knew anything about interest rates. But the second we get that new piece of intel, the news that rates will in fact be stable, we can just follow that specific branch on our tree. Our forecast isn't 234 anymore. Nope. Our new, much more precise, conditional forecast drops to $2.12. That, right there, is dynamic forecasting in act.
Okay, now we get to what I think is the most powerful tool in the entire kit. Seriously. This is a formal, mathematical, you could almost call it a belief updating machine. It's a way to rationally change your mind when you get new evidence. And it's so important because it helps us fight our own built-in biases. Things like confirmation bias or just being way too overconfident.
It's called Bayes' formula. And look, I know the formula itself might look a little intimidating when you first see it. But trust me, the idea behind it is actually beautiful and simple. At its core, it's just a logical recipe. It's a set of instructions that tells you exactly how much you should adjust your beliefs when you learn something.
We can actually break this whole thing down into 4 really straightforward steps. First, you start with your prior. That's just what you believe before you get any new info. Second, you assess the likelihood. Basically, how good is this new info? How much should you trust it? Third, you figure out the overall probability of even seeing this info in the first place. And fourth, you put it all together to calculate your posterior, your new updated belief. It's just a really disciplined way of learning from new evidence.
Okay, theory is great, but let's make this real. We'll use an example straight from credit analysis. Imagine you're trying to predict whether a high-risk bond is going to fail. You have your initial gut feeling or your initial estimate, and then you get a new piece of data. It's the rating from a fancy prediction model.
Okay, step 1, the prior. This is our starting point. Before we even look at the model, our baseline belief, maybe from historical data, is that there's a 20% chance this kind of bond will fail. Simple enough.
Now for step 2, the likelihood. This is where we figure out how good our new information is. And this is critical. The model is not perfect. In fact, we know that of all the bonds that actually ended up failing in the past, this model mistakenly gave a good rating to 50% of them. That's a huge piece of information because it tells us exactly how skeptical we should be of that good rating.
All right, let's put it together. We've got our initial 20% belief, and we've got this new good rating from a model that we know gets it wrong half the time on bonds that fail. So what happens now? It's time to fire up that Bayesian engine, plug in the numbers, and see how our beliefs should rationally change.
And here's our results. The posterior probability. That good rating is new evidence, so it makes sense that our belief should change. And it does. The chance of failure isn't 0, of course, because we know the model isn't perfect. But it's not 20% anymore either. Our new, updated, rational belief is that the probability of default is now 14.3%. That is the incredible power of Bayes' formula. It gives you a precise, logical reason to change your mind.
All right, let's just take a quick step back and look at what we've just put together. We've just assembled a really powerful toolkit for forecasting. We've gone way beyond a simple best guess and moved into a really sophisticated way of thinking about the future.
So let's recap the whole toolkit. First, we got our best guess with expected value. Then we measured the uncertainty around that guess using variance. After that, we learned how to map out all the different possible futures with probability trees.
And finally, the big one, we got our very own belief updating machine with Bayes' formula. You now have a complete framework to go from just having a hunch to making a real quantitative forecast.
Look, this entire toolkit gives you a clear, logical way to make decisions when things are uncertain. It's designed to help you fight your own biases and think rationally. But that leaves us with one last big question to chew on. In a real-world market, a market that's so often driven by pure fear and greed, is being rational really enough?